This is a demonstration of our TFI fault detector. I'm going to go ahead and run a lot here. And we have a simple package test. And this fault detector window, which is not normally up during operator use, is just for debugging, but it allows us to show during this demo the faults that are generated. Now in this case we see there's some calibration checks that failed. And then we also have a data logging check at the beginning of the lot, which means that the STDF file wasn't opened up. So we'll let this run for a couple minutes and we'll see that that's pretty much it for the faults, because I have all the thresholds on CPU, memory, and disk space set high enough that there aren't any faults. In the rest of the demo we'll show you some of the other faults that the fault detector can check. So I've restarted the fault detector, and we'll go ahead and restart the test program here. I'll pull up the debug window here so we can see what's going on. I removed the check for the calibration and the FPGA, so we shouldn't get any faults now. So as we're going through this, it's monitoring memory threshold for any process. So any process that goes over 4%, which is a very low threshold, should trigger a fault, and we'll see it here in the window. There we have one. And so this is showing that the bin starter process of HP 93000 has gone over the 4% threshold. Of course, in normal operation we would never set a threshold that low, but I'm trying to demonstrate that this can capture a memory threshold fault. So for example, if you set that up at 90%, which would probably be a more realistic threshold, you would detect any process that uses over 90% memory. So I went in and I changed the threshold for total CPU usage to 10%, and now we see that the CPU usage is failing at 11.8%. Let's go ahead and run the tests here, and I think we'll see that number climb up a little bit. So here you see it went up to 12.3. Naturally, we would never have a total CPU usage down that low. It would normally be up at like 95%, but this could send you a warning if for some reason a process went out of control and was using greater than 90 or 95% CPU usage. So far we've shown a CPU and a memory check, and there's also disk check, and we've also shown a data logging check. Sometimes it's important that a particular test program be run with a certain version of Smart Test, or that it be run in a certain mode, such as an operator mode rather than engineering. The fault detector has the ability to detect modes and parameters. So I'll show a demonstration of that. We'll go ahead and start this lot here. We'll pull our window up here. And at the very beginning of the lot, it immediately flags the fact that we're running with Smart Test version 7.1.3, not 7.1.2. Now that doesn't seem like it might be that critical, but sometimes there's certain patches or something in a newer version or an older version that you want to run with. We also see here that we're running in engineering mode, not in the operator mode that's required. So for either one of these, this could either stop the operation of the test cell, or it could send an email or some other action. So we've showed a few different faults that the fault detector can check. Here's the list of all faults. We have the memory, CPU, disk usage. We have missing processes. You can check if a certain process is running. We can do calibration check. And a really useful one is excessive time between states. If it takes too long, for example, to kick off a lot to fill in the operator information, you could put a 5-minute time limit on that. And if the test cell sits there without that information being entered, it can generate a fault. We can also check, as we showed, the Smart Test version, online or offline check, user mode, and the FPGA check is a check of the actual hardware FPGA version. We also have the data logging, and even UI report window warnings can generate faults. We've shown quite a few components that make up TFI. All of these components are built on a TFI framework. The TFI framework provides event reporting, which allows you to synchronize your components with events that come out of SmartTest or even custom events. It also provides uniform access to SmartTest APIs, such as the TPI, CPI, and HVM API. These are all APIs that allow you to control or query SmartTest, but some of these APIs vary across different versions of SmartTest. TFI provides a uniform interface to all of those APIs so that you can use them without concern for how they may differ from SmartTest version to SmartTest version. TFI also provides a test cell communication scheme using IPC, which allows your components to easily communicate with each other. Here we'll see a session of SmartTest running here, and I want to show you the events coming across here. So this is the tail of the event log showing the events. You can see in here package completed, test flow exec completed, and you can see all of the binning and the site insertions. If I go ahead and pause this, you'll see right here that we had a test program exec paused, and then we had an event dialog started. So these kinds of things are very valuable if you're trying to write a component such as an operator interface that needs to know when certain things within SmartTest have occurred so that you can synchronize with them. TFI framework provides all of that, provides the events, provides the uniform access to APIs, and it provides test cell communication using IPC. The TFI framework also allows you access to the components that are included in TFI, and that gives you information such as yield, bin counts, statistics, and it even gives you access to our prober and handler control, which means that you can talk to a prober or a handler from a test method, which is usually not possible with just regular SmartTest. Here I have a view of the SmartTest server log file, and it gives you an idea of some of the things that you can get out of the TFI framework. Right here we see get temp path, get file state, and let's see what else we see. Get parameter, so that you can go out and get parameters that have been seen by the EDL stream. Again, there we see another get temp path. So much of the information that's available behind the scenes may not be so easy to get, but with the TFI framework, we make that easy and accessible.